What's up guys, welcome back to the channel. Today we are going to be learning how to derive one of the most foundational equations in all biosciences. Today we're going to be learning how to derive the Henderson-Hasselbalch equation. Now, to understand what the Henderson-Hasselbalch equation is in the first place, we need to understand what are buffer solutions. Now, a buffer solution is a solution which resists changes in pH when small amounts of an acid or a base are added to it. So, just for the sake of explanation, if you have a neutral substance such as water and you add a little bit of an acidic substance such as lime into the water, the pH will reduce. And if you have a neutral substance such as water and you add a base, the pH would increase. Now, if this substance was a buffer, the pH would remain constant and would not change. That's all about what a buffer solution is. Now, the Henderson-Hasselbalch equation is used to calculate the pH of a buffer solution by relating its acid dissociation constant pKa and the concentrations of a weak acid HA and a conjugate base. So the equation puts into consideration all of these parameters. And therefore, the equation is pH is equal to pKa plus log conjugate base all over concentration of weak acid. Now, this equation was originally developed by a scientist named Lawrence Henderson and later modified by Karl Hasselbalch, hence the name. So next we are going to be talking about how we can derive this equation. The Henderson-Hasselbalch equation is derived from the acid dissociation constant Ka for a weak acid. So if our weak acid, which is Ha, dissociates into a proton and its conjugate base, Ka would be equal to all over Ha. So for the next step, we're going to solve for our hydrogen. So making hydrogen the subject of formula, that's our proton. We have H plus is equal to Ka okay. In the next step, we're going to take the negative logarithm of both sides. So then we'd have Now let's recall that minus log hydrogen is equal to pH and minus log Ka is equal to pKa. That brings our equation to pH is equal to pKa minus log Now all we need to do is rearrange this equation so that the conjugate base, that's this, is brought to the top. So we have pH is equal to pKa plus log conjugate base all over H, a concentration of your weak acid. And once again, you have your Henderson-Hasselbalch equation. Where the pH is the measure of acidity or alkalinity of the solution. The pKa is the negative logarithm of the acid dissociation constant, which also indicates the strength of the weak acid. A minus is the molar concentration of the conjugate base, and Ha is your weak acid. Now, the Henderson-Hasselbalch equation allows for the calculation of pH for buffer solutions and helps predict how much of a buffer will resist changes in pH upon addition of acid and base. And this principle is applied in biological systems where buffers, such as the bicarbonate buffer in blood, maintain pH within a narrow range. Also, we tend to use this equation when we are preparing buffers in the lab for running of chemical experiments. So that's all you need to know on the derivation of the Henderson-Hasselbalch equation at a very basic level. Next time on the channel, we'll be using this equation to calculate the amount of salts needed in preparation of a buffer in the lab. If you have any questions, you can let me know in the comment section. As always, please remember to give this video a thumbs up, subscribe if you haven't already, and let me know if you have any questions in the comment section. I'll see you guys next time. Bye.